Hi guys, hope you're fine and doing well. So today we will be discussing this problem from the Codeforces round 781, which is array cloning technique. So the problem says that we are given an array A of n integers and we can do some set of operations on them. And the operations are namely like we can choose an any array and clone it, and after that there is one more copy of the chosen array, and the second operation that we can do is swap two elements from any two copies on any positions. And then we are required to find the minimal number of operations needed to obtain a copy where all elements are equal. So the constraints of the problem are of the form 10 to the power 5. So basically the size of the array that we will be given is of the form 10 to the power 5. And by this we come to know that, and since the time limit given is 1 second, so we come to know that we cannot solve this question in n square form, since it will lead to 10 to the power 10 operations, and in 1 second generally we are able to do 10 to the power 8 operations only. So let's have a look at the test case and how we can approach this problem. So firstly, we are given with this array, and in one step what I did is, since I have to make all the elements equal, like if I want to make all the elements equal, then the array should look like 1 1 1, or I can do the other thing is like 3, I can make all the elements to 3. But the process to do that is like, firstly we are given two operations. So the first operation is either we can create a replica of any of these arrays. So firstly I created one replica of it. So the other operation that we can do is, out of all the replicas that are available to us, we can switch any two elements. So in one operation, like if I want to swap these two elements, I can do that. So this element will become 1, and this element will become as 3. Similarly, if I again swap these elements with this, so it will become 3 and this will become 7. So our new array will look something like 0, 3, 3, 3, 3 and 0. And the other array will look something like 0, 1, 1, double 7 and 0. So basically we have performed till now three operations. The first operation was when I created replica of this array. The first operation was that. Second operation when I swap these two elements. Second operation, and third operation is when I swap these two elements. So till now we have completed three operations, and till now we have not been able to make any of these arrays as equal. What other operation we can do is, I will create replica of this array. Let me create it. Yes, so I have created this as the new array. And now I will be performing the operation. Yes, now I will swap this 3 with this 0, and there should be one more 0 here. Yes, and this 0 with this 3. So finally the array will look something like 3 and 3. So the total number of operations from the starting, let's see that. So the first operation was when we created replica of this, the first operation. Second operation when we swap these two elements. Second when we swap this, third, and fourth operation is when we created replica of this, so which is this array, and fifth operation is when we swap this 3 with this 0, and the last operation is when we swap this 3 with this 0. So hence we have been able to make this array as equal, so all the elements of the array are 3. So let's confirm that for this test case is our answer right. Yes, for this array that we are given, our answer is 6. So the first observation that comes up to our mind is that if we are given any set of elements, like here we have given 3370, so which is the most feasible option that we should do so that we can minimize our operations. So the best case scenario will be when we will be trying to make our array elements equal to that element whose occurrence is maximum. Like in this array, 3 was occurring 2 times and 0 was also occurring 2 times. So either we could have made this array to 0 or 3. So these operations would have given us like the minimum operations. So now let's see how we can keep a track of the count of operations in a systematic manner. So just let me clear this out. And yes, so the element x that I have, so basically this is the array that is given to me. So I have considered that I have x is the element which has the maximum occurrence in the array. So I have kept all other places as empty because I am not concerned about any other element now. I am just focused to make all the elements of this array as x. So I have created a replica of this. So now I will I have done this first operation by creating a replica of the given array, and now I will be just swapping. So whatever element is on this index, I will be swapping with it x, and similarly I will swap with this x also. So till now I have created these elements as x and x. So I have to create all the elements. Still I am left with many positions. But since I have swapped these to x, so these will not be available here. So some other element will obviously be here, which was present here. So now this array that we created was of no use. Now we will do another operation. We will create a replica of this array. Now, since we created replica of this array, so this operation will also count. So now we are provided with 4x. Let me change the color. Yes. Now we can fill these x as, we can fill this here, we can fill this here, and similarly. So we get all these x here. So let me fill this. So again, all these values are not of a concern since they have been swapped. Now, I am still left with two places pending. I will I will see if any other replica of these arrays that I have created is containing this value x. Since this array is also not containing and this is also not containing, so now we have no choice but to create another replica of this array. So we will again create replica of this array. And Now again, we have since these two places left. So here are 8x available to us. So we can swap these two places with any of these x. Like I use these. So my new array will look something like x, and these two will be replaced by these two elements that were previously present here. But since we are not concerned, so I have not written those. So if we clearly observe that now we have made our array equal, where each element is basically identical. So now if we want to count the total number of operations, so the total number of operations in this whole process is, like, firstly we need to observe that we were given these two, and we created this replica. So for the replica there is first operation, and then we swapped these two elements with here, right? So next, for the change, so I am, for the R I am referring to replica, and for change basically is the swap. So let me write it like S only. Yes. So S represents swap. So we did then two swaps. So here two operations were involved. So next we were left with these many places, right? So but there was no other array. So we created another replica, which was this. So we created another replica, and again then we swapped these four elements as here. Then the chain basically the swap was 4, and again then two places were left. So we were left with no other uh, arrays that contain this element x. So we had to again create a replica of this array. So again the operation that was involved is another replica, and then two places were left. So we swapped these two places with these two. So yes, so swap operation will take 2. So if we add up all these, so basically it will come out to be 3, 4, 8, and 11. So in total, we took 11 operations to make this array equal. So the one of the observation that we see is that firstly when we were given with two elements of x, then we created a replica of it. So basically two elements, we got another two elements, and after we created replica of that, we got four elements. And then when we created another replica, so we got eight elements. So every time we creating a replica, we are always getting twice the elements that we got the previous time. So like if we were given with three elements of x in the starting, then we would have got, when we created the first replica, it would have been 3. Then the next replica would have been 6. And in the last, we were provided with 12. So these are like the set of units of x that we are every time provided when we create a replica. So the main question arises is when we need to create a replica. So let's see that. So firstly, when we were given these two elements only, so the places that we had to fill was basically n minus the count of original, basically the n minus count of x. C of x is basically the count of x, right? So it was 8 given to us. So we needed 8 x items. So we started, so firstly we created first replica. So then we got two elements. So we filled up these two elements. So now the total number of places that were left were 6. So the next time we created another replica. So we again swapped these four elements, and the only places that were left were these two places. So for them, we created another replica of this whole array. And then we got 8 units, but we just required only two places to be filled. So then only these two, then we swapped these two elements. And hence for these, only two operations were considered. And for this part, the total number of operations that were made were, firstly, the replica was made and then they were swapped. So 4 plus 1, 5, which was for the replica of it. And here also, since we required two elements, so 2 plus 1, 3, which is like 2 for swapping them and 1 for creating the replica, right? So basically this contributes to yes, 10, and this the replica that we created of the original array was for the 1. So these are basically contributes to total 11. So this is how our answer is being built up. So now let's see how can we code this problem. So this is what my code looks like. Yes. So firstly, I took the input for the test case, and then I took the input for n and all the elements of the array, and then I sorted this array. And why did I sort this array is because I wanted to know that if already all the elements are equal, so I don't need to perform any of the operations. So here, if after sorting, if my first element of the array is equal to the last element of the array, then I definitely in between elements are also equal. So no operation needs to be performed, and simply we can like return 0 from this part. And in case we have to like keep count of all the occurrences of elements. I have created this hash map which keeps count of all the elements, occurrences of all the elements basically. And this max variable stores like which is the maximum occurrence that occurs, not the element that occurs maximum times, but the count of occurrence that is maximum. And this required variable contains like the number of places that need to be filled by that element. Like for this case, required variable is this part, represents this part, which is 8. And next variable I have created, which stores like every time we create replica, so how many units of that particular element that we want to fill is available to us. And then I have created a count variable, which is 1, because whenever we are provided with the array, so the first operation that we will be doing is create the first replica, because without that it won't be possible to fill up all the any next place. So that is the reason I have kept the count is equal to 1, and the current stores that how many units I have available in this current replica. Basically what I mean to say is my current will represent 2, which is this part of the replica, and my next will store 2 star 2 basically, which is 4 elements, which will be available to me when I create next replica. They are not actually available to me right now, but they will be available to me if I create. So these are the variables, and this part of the code basically I have run while loop, wherein this means that I have to run while loop as many times for counting the operations till there is no empty index left. So basically when required will be equal to 0, so like required will be equal to 0, like then no place will be left for me. Hence all the elements will be equal. So if this required variable is greater than or equal to current, so currently like we are having this 2, so this required variable which is 8, so it is definitely bigger than this current variable. So what I will do is simply required will be reduced by all the like current elements that I have, which is 2. So my next required will be this 6. And once this is done, then for the next part, I will just initialize current as 0 because I have currently no other units of the element available. So once I have initialized this current variable to 0, then the next step that I will be looking for is that do I have more places to fill? If not, then we will just break out of this loop. And if yes, then the next step that we will check is like, do I have more units of that element available? Since for this case, when we initialized the current to 0, then we don't have any other units available. So what we will do is we will add more units. How we will add is we will just create a replica, and this is where the next variable will come into picture, and we will just initialize current with next, and then we will do a count plus plus for creating a replica because this is also one operation, and then I will initialize the next to the double of current. So this loop will go on, hence we will be keeping count of all the operations, and we will be just simply printing the count variable. So I hope you understood the solution to this video, and if you appreciate my work, you can consider subscribing to my channel and giving thumbs up to this video. So let's meet in the next video. Till then, bye bye.